Okay, so we're going to continue for symmetry and surface area, and we're going to continue looking at types of symmetry in two-dimensional objects, and we're going to look at rotational symmetry in this lesson. And so for rotational symmetry, you need to be able to recognize, first of all, if a shape has rotational symmetry and know what that is. And we're going to look at the order of rotation for shapes and the angle of rotation for shapes. So, looking at these objects, and I know in your notes they are in black and white, and the same with line symmetry, color is important. On the square and on the hexagon, we're going to ignore the shading color. We're going to assume that they're fully colored in. I'm not sure why my color changed like that. They are all purple. Let's go with that, okay? And so when we look at rotational symmetry, these shapes are all examples. So if you watch when I rotate it, I don't know if you can see in the background, kind of clearly there's another shape there. Anyways, when I rotate it, this card is the same upside down as it is upright. So it has 1, 2 times that it looks exactly the same. When I look at the square, it has 1, 2, 3, 4 times that it's exactly the same. When we look at the dollar sign, there you can see that image a little better behind. It has 1, 2 times that it's exactly the same. And the hexagon has 1, 2, 3, 4, 5, 6 times. It's exactly the same. And so, again, you have a box with a word in it. So I would like you, for yourself, either using the glossary or the internet or whatever, to come up with some kind of definition for yourself of what rotational symmetry is. And I'm going to get water. Okay, that's better. So rotational symmetry, hopefully you discovered, is when a shape can be turned around its center of rotation. And so when we say center of rotation, what we mean by the center of rotation is the point that we're turning it around. So if we went up to the card, this was the center of rotation. If we looked on square, that was the center of rotation, center of rotation. And so for all of these shapes, we're using the center of the object as the center of its rotation. And so for rotational symmetry, when you turn it around the center, it fits into its own outline more than once in a complete turn. Any shape will fit back into itself once you've done a full turn. So just that fact that it fits once doesn't make it have rotational symmetry. It needs to fit more than just that one full turn in order for it to have rotational symmetry. Okay, so when we look at these examples, again, keeping in mind that color is important. And so when we look at the flag, bonus points if you know where this flag is from without Googling it. And I turn it once, it's not the same. If I turn it twice, there we go. So if I turn it halfway around, it's the same. Not the same, the same. So yes, this shape does have rotational symmetry because it fits 2 times into itself. When we look at this one, hopefully you can see that no matter how I turn it, it's not going to fit into its original outline again until I get all the way around. So this one does not have rotational symmetry because it only fits into itself 1 time. And on the last example, this is like a pinwheel. Okay, so it fits 1 time, 2 times, 3 times, 4 times. So yes, it does have rotational symmetry because it fits 4 times into itself. And those are times is not 4x, 1x, 2x, just to clarify. Okay, looking at this one, this is a super hardcore pinwheel, and so we want to look at this one and see how many times will it fit inside itself. So hopefully you notice that it has 1, 2, 3, 4, 5, 6 identical, I guess, pieces. And so when I turn it, it will fit 1, 2, 3, 4, 5, 6 times into itself. So it fits 6 times in one full rotation when we rotate about its center. So there's the center of rotation. And so then it says, what is the minimum angle? Well, if I turn it in a complete circle, it goes 360 degrees. And I moved it 6 times. So each of those 6 times is going to be an equal angle. So 360 degrees divided by the 6 times will give me the minimum angle, and it's 60 degrees. So every time I turn it 60 degrees, it will repeat the starting shape. Oh. Okay, so looking at these next examples, we have 2 more boxes, order of rotation and angle of rotation. And so we actually just showed what the order and the angle of rotation are. And so using either the last example or using the internet or your glossary, please fill in those 2 boxes. So order of rotation is the number of times a shape fits into itself on one turn. So if we look back at the last pinwheel example, at the bottom here, this 6 times, this is the order of rotation. And so the degree, so the angle of rotation, is the smallest degree or the minimum degree needed to turn a shape so that it fits its outline. So this is the angle of rotation. And so it's the smallest angle, and so the way that we find it is we take the 360, which would be needed to make the 1 full turn, and we divide it by the order of rotation. And it gives us the angle. And we show that that number is an angle by showing the degree sign. Okay, so for each of these next examples, we're going to determine what the order is and what the angle is. So in this column, we're going to put the order and then the angle. And so if you look at the shape, how many times can I turn it to fit its original outline? In 1 full turn, I can only fit it once. And so the angle of rotation would be 360 degrees divided by 1. So 360 degrees. And so we would say that this shape has no rotational symmetry. Because it only fits after you've turned it around 1 full time. Okay, again, bonus points if you can guess this next flag without having to look it up. And I know you all just Googled it because you're a bunch of cheaters. So when I turn it halfway, I make the same flag again, and when I turn it fully around. So this shape fits into itself twice, so the order of rotation is 2. And to find the angle, we take 360 degrees, divide it by 2, and so the angle is 180 degrees. Looking at this last shape, it has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it is an octagon. And when we turn it 1, 2, 3, 4, 5, 6, 7, 8 times, it will fit inside itself. So the order of rotation is 8. The angle of rotation, we get 45 degrees. So hopefully those are nice and simple for you. So this last table, I want you to fill in what type of symmetry. So does it have line or rotational symmetry or both? If it has line symmetry, I would like you to tell me which direction of line symmetry it has, or none at all. Or if it has rotational symmetry, I would like you to tell me what the order and angle of rotation are. And we will check this in class tomorrow.